Thinking about biodiversity, most of us think about biodiversity in terms of how many species are out there. But I want you to start thinking about biodiversity beyond species. I want you to think about biodiversity in terms of genetics and in terms of landscape, and how all three of those things work together to create diversity in species populations and sustainability of individual populations. So we've our mascot for YSU is the penguin, so I thought I would pull up a couple of penguins. I will let you find the penguin that is our mascot on this screen. Um, but in making you look across the screen at all these different penguins, there's some characteristics here that are common amongst all of them. Their flippers, which are their wings, are made for swimming, not for flying. The general body shape is distinct for all of these species, but then there's some significant variations: beak variation, plumage variation, size variation is all critical. And every one of the variations that you see on this screen is a byproduct of the structure that was created because of the location that they were found in or moved within. So we've got lots and lots of variety, and that variety extends all the way from the Antarctic through to the Galapagos. In this quick diagram here, I've got two species that I'm underpinning, and one of those species, these guys who look like they should belong in British Parliament, and because they've got these crazy eyebrows, can be found in New Zealand, Tasmania, Australia, and then all the way across in Madagascar. And that has something to do with geologic history. Likewise, these gorgeous little guys down here are found all the way through the west coast of Chile. And this is important because we're moving across a lot of different climate zones. We're going from high mid latitudes here to equatorial regions. So there's a huge temperature range across here that these guys fit into, and their geologic historic condition has to do with how the continents were arranged, just like how these were rearranged. So there's a long history there that I'm going to provide with this diagram. So these are all the locations where we have penguins and penguin varieties, starting with the Galapagos Island right here on the equator through to the west coast of South America. All these islands across the Southern Ocean and the South Atlantic and South Indian Ocean. Africa, we're missing the ones here that should have a couple of dots on the bottom here in Madagascar, the southern portions of Australia, New Zealand, and then these various islands, and then everything through here across Antarctica. Please note, nobody in the penguin family lives up here. So all of those Christmas commercials with polar bears and penguins, Coke has it wrong. I'm sure lots of people every year tell Coke that. But what is going on here is there was a common penguin ancestor back when Pangaea was together, and we'll talk about plate tectonics when we get to geology, but this continent and this continent were attached to Antarctica at one time. And you can kind of see this divot fit in down here, and South America and Africa fit together, which meant this portion of Africa and this portion of South America fit together. And this portion of South America actually lay against Antarctica. So historically, all of these penguins were kind of in close proximity on one giant continent way back when. And as plate tectonics moved, they took some of their penguins for a ride, and this migrated to more northerly climates and warmer climates, and so did these, and then so did these. And in doing so, as the climate changed, the vegetation changed, the geology was influential, and when the landscape changes, your ability to acquire energy has to change as well. And if you've got the right morphology, the right structure, you're going to be successful. So because movement tectonically takes millions and millions of years, genetics has millions and millions of years to adapt. So consequently, we get wildly diverse species of penguin across a very large south hemisphere landscape, with the exception of here, which is right on the equator and scant into the northern hemisphere. So if we were to just look at what's going on with New Zealand, we can see just how specific these niches are for these penguins. So the blue fairy occupies the greater part of the aquatic landscape and terrestrial landscape of New Zealand, and Chatham Island out here. There's only this little stretch where the landscape is not preferred for this species. It does not do well there at all, so it's lost to this place. We're not going to find that species here. The Fiordland crests are found where there are fjords in New Zealand, so only along these landscapes. Yellow eye doesn't do well where there's fjords, but does well across this landscape. And where we were missing the blue fairy and where we were missing the Fiordland crests, yellow eyes can be found, but just only on part of that landscape, just on the very tip here. So the conditions that are right for this guy exist in these very specific islands and only along this eastern shoreline, southeastern shoreline. White flippered, even more specific, likes where the little blue fairies aren't. In fact, maybe there's competitive exclusion happening here. There's no blue fairies because the white flippereds do well here. But the white flippereds do okay with the yellow eyes, but as long as the yellow eyes only exist here. So this is their habitat, and then these poor snars are found on this itty bitty tiny little island right here, nowhere else. So the less landscape that you occupy, the tighter your niche is. So if anything changes, you're really vulnerable to extinction. So the snares, with his gorgeous eyebrows, his gorgeous plumage, is a really vulnerable penguin species throughout the New Zealand landscape. Or the blue fairy, if there's change that's going to happen on the landscape, he has the better opportunity of success. He may lose some habitat in some locations, but he may be successful elsewhere. So that's really important there. So if I was to bring all these ideas together in terms of diversity, when we've got ecosystem diversity, we're going to have specific ecotypes or species types emerging. Those species types are only capable of emerging if you've got genetic diversity, and genetic diversity occurs with genetic spontaneous mutation, where specific traits then occur. Most of those traits that spontaneously mutate, and we all have mutations, are benign. They are not problematic for us. We do know that there are mutations that are problematic, but for the most part, most of those are benign. When they become beneficial to when a landscape changes, then those individuals with those traits then will become most successful on that landscape. and be the primary inhabitant of that landscape. So think of the little blue fairy. Has a great range, has the genetic makeup to occupy lots and lots of landscape, and maybe has more flexibility if with climate change it can adapt to new landscapes in the future. Snars has a very tight genetic propensity for one island. If under climate change it's favorable to Snars, he may find his range grows. If it's unfavorable, then we're going to see the loss of that particular species. So in order for there to be species diversity, you need ecosystem diversity and you need genetic diversity. All three of these diversities go hand in hand for success. And that brings us to the end of biogeography for this semester.